Okay, we've talked about concrete up to this point in time. What I'd like to talk a little bit for a few minutes here is the steel that we're going to put in concrete, or the reinforcing. Concrete is good in compression, not so good in tension. We better have something that's halfway decent in tension so that concrete can behave structurally. It'd be nice to say, oh, our concrete structures are only under compression, but let's see, that would sort of rule out beams, because beams have tension and compression in them. It'd rule out columns, because again, columns are cast monolithically with everything else, and so there's going to be bending moment placed in columns. Hey, there's tension again. Even our footings, our footings, believe it or not, are going to be subjected to bending, and so there's going to be tension where the soil pressure pushes up on one side of it or down on one side of it, or like that. Retaining walls, hey, we're going to have soil pushing on that. Foundation walls, soil pushing on it, there's going to be tension on a certain side. We've got tension in our structures. We better have something that can resist tension. Steel is pretty good. All right? Steel rebar, steel bars is typically what we use. We can use steel mesh in some other applications, welded wire fabric mesh. We won't talk about that in here, but we can use it. You could use other things. There's other things that you can reinforce with. If you go to other parts of the world, maybe not as developed as our country, but nonetheless other parts of the world, they still reinforce concrete with bamboo. Bamboo is very tough, strong wood, plentiful. They've used it successfully in concrete. Not high rises or anything, but water retention facilities, things like that, tanks, they've used it. So again, you could use other things. Plastics, people are doing a lot of testing with plastics now. Carbon fiber, graphite, the different composites. There's a lot of stuff being used right now, but we're going to talk about basic steel. Okay? With steel, we know that steel, what properties it has back in strength of materials. We ran a stress strain, a tension test that gave us the stress strain diagram. And we know that there's an important point that occurs up here, and we call that the yield stress. We like to signify that as Fy. Okay? There's another point after the steel starts deforming greatly, going through its plastic region. There's a maximum stress up here. That maximum stress, once it's hit, we call that the ultimate stress. Again, in structural steel, we call that F sub U. Okay? We don't really care too much about ultimate stress here because we're not thinking our rebar. We don't really want to push the rebar to where it snaps. That might be a bad thing. But yield, we'll use yield stress a lot. Okay? We also know from structural steel there's a lot of different types of structural steels. There's different types of reinforcing steel too. Typically, we'll call out reinforcing steel by a grade. So we use a little bit different terminology. We'll say, oh, this is a grade 60 steel rebar. What a grade 60 steel rebar means is that that has a yield strength, a minimum yield strength of 60 KSI. You could hear people using grade 40s, although that's not very common. Grade 50s, but again, not very common. There's higher grades. We can have rebar that go up to 80 and 100 KSI. again, not super common, but I'd say the 99% of the time what you're going to see is grade 60. Okay. So steel's good in tension. As concrete cracks, we'll learn this later on, as concrete cracks, it's supposed to be that steel bar that takes that tension stress, that holds that crack from developing, you know? So we better have our rebar placed in the right location, or, like if I had a beam, I better know where the tension side of the beam is, because if I put my tension reinforcement on the compression side, it's not going to do me a whole lot of good. All right? The steel, the other thing you should know is the different sizes, typical sizes of steel rebar. In your book, or any book really, I mean, you can go to chapters, whatever. You can always go to resources. You can go on the web and find out the various sizes of rebar. You can go in your chapters, you can go in the appendix of your book. In this book, the very first appendix that you have, and it's probably even in the chapters as well too, has a table with the various sizes of steel rebar. Typically, steel rebar, we'll talk about it in numbers, and it'll basically go from a number 3 through a number 11. And a number 3 means that you have a 3/8 inch diameter. A number 4 means you have a 4/8 inch diameter, a 1/2 inch diameter. And that goes pretty well until you hit about number 9, number 10, number 11. Then it's not perfectly 1/8 inch anymore. There's a little variation. But, if you're ever out there in a field, you don't have a book or a reference right in front of you, you can always say 1/8 of an inch. So what you want to know is the diameter, or have that available to you, what the diameter is. And then also, more importantly, what the area is. So diameter and area. We're going to want, again, whether it's in an appendix, chapter, other resource, whatever, know what diameters are of the bars, or have that available to you. What the diameters are, also have what's available to you as far as the area goes. If you're doing construction estimating, you'll probably also want to know the weight of the rebar per lineal foot. We don't get into that here, but an estimator would. They want to say, oh, I'm taking off this whole project. I want to know how many pounds of reinforcing steel I have. So they're going to have to, hey, I got this many lineal feet of number 3 bar. I have this many lineal feet of a number 10 bar. Whatever. Okay? And so that's, that's a little bit about steel. Again, find the resource, appendix, chapter, out there on the internet. Just make sure you have that available to you.